In this video, I'm going to continue my practice questions for grade 12 general. We're starting on to some term 2 questions about circuits. So let's get started on this one. We have a potential difference question, DC, but there's two ways to solve this one. We're trying to figure out the voltage here. You can clearly do V equals IR if you had the current, which we don't have. We can find it, of course. You can find the current in a series circuit very easily. Let's do it that way. I'll show you the other way as well, the voltage divider. First thing I'll need to do is figure out the current in the circuit before I can do V equals IR for this one. I equals V total divided by R total. In series, you simply add the resistors. I'll do 90 and I'm going to divide that by 15. If I was to put that into my calculator, 90 over 15, I will get 6 amps. So my current is 6 amps. I can now find the voltage just by doing 6 times 5. 6 times 5, multiply 6 times 5. If you're not good at math, you can use your calculator. That will obviously give me 30. And that means the answer is B. That's one method. There is another one, a quicker one, an easier one that I prefer, is the ratio, the voltage divider formula. If you have 2 resistors and a battery without a current, you don't need it. Let's try it. V out, which is the V that I need, is the input voltage of the battery, whatever it is, multiplied by the ratio of the resistors, R over R total, RT for total. So the V that I'm looking for is 90 multiplied by how much the 5 is going to take out of the total resistance, 5 over 15. 90 times 5 over 15 is basically a third. A third of 90 is 30 volts. So that's another way you can maybe check your answer as well if you're not sure. Over here, the circuit shown, V2 is here, and that, well, this is 80 and we don't know V1. We need to find it. Two ways to do it. You can originally notice that if I have doubled my resistance, it's directly proportional, V equals IR. If I double my resistance, I will double my voltage. So straight away, I know it's going to be 160, but let's verify to make sure. In order for me to do it, just like previously, what I can do, what I can do is I can find the current flowing through it. I don't have the power supply, I don't have this, but I do have these two. If I figure out the current here, it's going to be the same current here in series. So I'll just do V over R, double check it, 80 over 20, 80 over 20. Of course, if you don't know how to do it, you can use your calculator. Not saying that I'm using it, but you can. That'll give me 4 amps. Amazing. Now, let's find the voltage. V equals IR, right? 4 times, now this one, 40. 4 times 40 is 160. So my answer was correct. So this is going to be D, 160. So you can use the calculation method or you can use your brain. The numbers might be different in the final exam. Who knows? Okay, so we have a battery. This is 15 volts. I like to label the diagrams. This is R1 is 16 ohms, 14 ohms. Find the voltage across R2. I'm going to go ahead and use a voltage divider. I prefer that method. It's one-step solution. So V out, which is what I need, V in from the battery multiplied by the resistor ratios. So that's going to be R1 I'm looking for. No, I'm looking for R2. That's 14 divided by the total resistance. 16 plus 14 is 30, I believe. So V in, I have V in. So why don't I just go ahead and put the number in? It's multiple choice, you don't need to show the steps. 15 and put that into the calculator. Hopefully I should get 7 volts. Amazing. Alright, what's happening over here? A resistor is connected in series with another one and it's connected to a power supply. I like to draw a picture so I know what I'm doing, so what I'm going to do is draw it. Here is a power supply, there's a first resistor, there's the second resistor. What does that mean now? This is 150. 2 resistors, do we have the values? Yes, we do, 30 and 20. So this is 30, 20 ohms. Calculate the total resistance. Well, you just add them, right? So I will do R1 plus R2. Now what's happening here? R1 plus R2, R equals, I'll write the formula. And then I'm going to do 30 plus 20, which is 50 ohms. Formula, numbers, answer, unit, very important. Current passing through each resistor, well, that's one singular current flowing through both resistors, so you have to take the total resistance as the V over R total. So I'm going to do my V, which is 150, and I'm going to divide that by, it was 150, right? Yes, 150 over the total resistance of 50, and that will give me 3 amps. Amazing. Okay, let's continue on. Find the voltage across each resistor. Well, that's fine. Now that I have the current, I can do it. I can simply use Ohm's law, or I could use the voltage divider again. Either way, it will be fine. I'm going to go ahead and use Ohm's law this time, just to spice things up a little. This is 3 amps, and same current flowing through the whole circuit, all 3 amps. I don't know why I drew 2 arrows. So V equals IR. Let's do it. V equals IR. So I'm just going to go ahead and do 3 times 30. 3 times 30, of course, is 90. And I'm going to get 90 volts. For this one, I could do the same thing, 3 times 20. Or if you realize that if my total is 150, this is 90, I can simply do 150 minus 90. What's 150 minus 90? I think that's 60. 60 volts. If you don't believe me, let's double check. Let's do V equals IR, just to be sure. 3 times 20, that is definitely 60 volts. So the answers are here, but yeah, you can put them there. Calculate the current flowing through the 40 ohm resistor. Okay, and this is a little bit of a trick question. They might think that, oh no, you don't have this voltage, you can't find the current, it's different. No, it's the same current. As I mentioned, the same current flows through both of them. So I know I want the current as specified, the first resistor, 40 ohms, but if I can go ahead and use this, I will find the current easily. I equals V over R. It's just the same question as before. 80 over 20. It is the same question. I remember doing 80 over 20 not so long ago. So anyway, that is 4 amps. Voltage across the 40 ohm resistor. Yeah, so I'll just do V equals IR. Nice and simple. V equals IR. I is 4 times 40. 4 times 40 is 160, which makes sense because this is doubled this, but I've calculated it this time because it did say calculate. Find the voltage across the power supply. Alright, well if that's 160 and that's 80, well that's easy, I just add them, right? V total is V1 plus V2. In series circuits, the voltage, you just add them. 160 plus 80 equals whatever that is. I'm too tired to think. Let's just use the calculator, shall we? 160 plus 80, and that will give me 240. Very nice. 240. Find the equivalent resistance. You just add R equals R1 plus R2, and I am going to go ahead and do 40 plus 20, 60 ohms. That's an ohm, by the way. Yeah, that was terrible. There you go. Okay. Next, we're going to go over to some of this parallel circuit questions. So you should probably watch my video about series and parallel circuits to refresh yourself if you've forgotten. That's in my channel as well. They are 15 volts, 4, 3 and 12. Find the total resistance. In parallel, you do the 1 over rule. So 1 over R. But if you know the trick, I can directly get my final answer by simply just doing R equals, and I will have a bracket, 1 over R plus 1 over R plus 1 over R, there's 3 of them. Close the bracket to the power of -1, directly you'll get your final answer straight away. You don't need to do any flipping or anything, so that's good. So let's try it. 1 over, what are the values? 4, 3 and 12. 1 over 4, 1 over 3, 1 over 12. Bracket -1. Sticking that into your calculator, you will hopefully get your answer of 1.5 ohms. 1.5 ohms. In parallel, it's always smaller than the smallest resistor, so smallest is 3, that's smaller than it, so it looks about right. The total current, same idea, Ohm's law, V equals IR, or I can rearrange, I'm going to rearrange this time, V over R, and what I'll be, yes, 15 equals, not 50, 15, how did I do that? 15 over this resistance, 1.5. 15 over 1.5 is simply 10, and the unit is amps. Formula, numbers, answer. Unit is in amps. Okay, so now we've got another parallel circuit. We need to find the readings, and let's see, we have a 12 volt battery, 12 volts, and then we have, what's this? R1 is 2, 4 and 4. 2 ohms, 4 ohms, 4 ohms. Find the total resistance. Okay, so that's easy. 1 over. Just to speed things along a little, I'm just going to go ahead and do the numbers straight away. You should do formulas, numbers, answer every time. Why does it do that? 1 over 2 plus 1 over 4 plus 1 over 4 in a bracket -1. And if I do that, I should get 1 ohm. Very nice. Okay, great. Next. Find the readings of ammeter 1 and 3. Okay, so ammeter 1 is connected straight to the battery. So it's connected to the whole circuit before it splits up and goes its different paths. So this ammeter 1 is the total current. So that's important to know. I is V over R. V total over R total. 12 over 1, which is 12 amps. Not much needing done there. A3, I should probably call this I1, I guess. And I3, the ammeter A3, call it whatever you want. So V over R, right? In this case, they're all parallel. The voltages are the same in parallel, if you remember. So I need to know the current flowing through this one specifically. Only this one here, because that's where A3 is. This branch is the last branch. Not here, not here, not here, just this branch. So I'm going to use the voltage divided by that resistor only. V over R3 only. The V was 12 and R3 was, what was it, 4? 4 ohms. 12 over 4. 4, 8, 12, that is 3 amps. It splits up, so you can figure out the resistance in each of the branches, and they should all add up to 12 amps in this case. Find the energy dissipated in resistor R3 in 4 seconds. Okay, well, energy is power multiplied by time. We don't have the power yet, but we can find the power. That's easy. PIV, P equals IV. I'll directly put IV into here, and I'm going to multiply by time. We know the current flowing through that resistor because we just calculated it to be 3 amps, multiplied by the voltage across that resistor, which we know is 12. Multiply that by the time, which is 4 seconds. Directly you'll get your answer, and that should be 144 joules. The unit for energy is joules. So which is the reading of the ammeter A and the direction of the current? Okay, so let's see what we have here. We have a junction. We have 3 coming in, 2 coming in, but then we have 4 coming out, 1 coming out, and 2 coming out. So let's see how much is in, first of all. This is Kirchhoff's law. So in we have how much? 2 plus 3. What is that? 2 plus 3 is 5 amps. Out, how much do we have? Let's check. We have 4 plus 1 plus 2. Out, out, out. So that is 4, 5, 6, 7 amps out. Look, they're not equal. This is only 5 in. That means this one must be coming in. It must bring in enough current to balance this. If that's 7 amps out but only 5 in, I need to add 2 amps to get it. That will give me 7, which is balanced because the current coming in must equal to the current coming out. Kirchhoff's current rule. So this will be 2 amps coming in. 2 amps into the junction.